Topic 2.1.1 wants you to be able to outline the architecture of the CPU, including the ALU and the control unit, and also be able to talk about the memory address register and the memory data register. So here's a diagram. I've included other stuff, so I'll explain the other stuff first. I've got the hard drive and the RAM and the cache, and that is the way that data flows. Programs are loaded from the hard drive into the RAM, and then between the RAM and the CPU, those instructions and data go back and forth, back and forth, back and forth via the cache, and so the common things that are done over and over again get left here, and so it's back and forth, back and forth, back and forth here. So, in terms of the ALU and the control unit, the ALU is the arithmetic logic unit. It does arithmetic and comparison operations, and that's it. And then the control unit, it specializes in moving stuff everywhere, moving data and addresses everywhere. So back and forth between the RAM via the cache, but also within the CPU. It controls the movement of data around the machine. Then there are the two registers, specific registers that are mentioned in 2.1.1. The memory address register is a register which contains the memory address of stuff to be fetched. So if in the memory address we've got 11111100, well, we go to that memory address starting right here, and we fetch whatever's inside it. And what happens to be inside it in this diagram is 00000011, which is 3 in binary. So memory address has the address from which we fetch data. And by the way, this is another assessment statement. We're fetching it via the address bus, and we are returning the data versus the data bus. And so the data via the data bus goes to the memory data register. So that basically covers those four things mentioned in 2.1.1. Just a little bit more about what I've got diagrammed here. I mean, there's no use loading something if you don't do anything. So what I've depicted here is once you've loaded some things, they would go to other registers like the instruction register and so on. So we will assume that in a previous cycle that add had come in, that 2 had already been there, and now that we've got 3, the ALU will add 3 to the 2 already there and give a result of 5. And so if we carried this forward, then the 5 would go into the memory data register and would be sent via the data bus to some other location, free location in RAM.